Let's keep moving here and kind of add some more clarity as we go to the process of oxidative phosphorylation. So we said the electron transport chain, there's the donation of electrons to the chain coming from our carriers. So remember NADH carrying electrons here, NAD is then converted to NAD+, so those electrons are kind of grabbed off of this carrier. Same thing with FADH2, we simply grab those electrons off, right, and we end up with FAD. And we take those electrons to the complexes, and as we pass them from one to the other, oxygen must be standing by to grab those final electrons at the end, okay? At the end of this process, we should end up with NAD+, which are our carriers, FAD as well in the oxidized state, some water, because as oxygen grabs those final electrons, water is created, and then we are able to phosphorylate ADP and make ATP. Now, you may see some discrepancy in the numbers here. And so your textbook usually gives, I think, 32 ATP, 28 of which comes from electron transport chain. But then you may also see other texts that say of the 38 ADP, 34 are coming from the electron transport chain. So there's some variation across physiology, some variation across different texts. But as far as our purposes, I want you to stick with what the text has, which is 34 ATP coming from the electron transport chain of the total 38 that we make. Okay. Let's look here again at what's happening. So I'm going to walk through this series of steps here that kind of talks about how these electrons are passed from complex to complex and how hydrogen ions are pumped from the matrix over into the intermembrane space. Okay. So basically we've got our electrons being shuttled from complex 1, complex 2, although it's not shown here, complex 3, complex 4. And then we have oxygen standing by here to get the electrons at the end here and make water. And then this gradient that we've now created by the passage of these electrons and the pumping of these hydrogen ions is now what facilitates the movement of these ions down the ATP synthase and what facilitates the phosphorylation of ADP and the creation of ATP. Okay. So just to reiterate what we've said so far and to talk about this a little bit more. Now, if we look more holistically at the entire process, we can kind of make sense of the shuttling of electrons happening here, of how many carriers we're making at each step. So this is a really good summary table to make sure that you have this, right in your mind in terms of what processes make what products and, how many and so on. So this is a great place to kind of try to recreate this drawing and make sure that you have it understood correctly. And so at the very end here, we see that our reduced form of our carriers are now converted to the oxidized forms here. And essentially we've grabbed those electrons from these carriers. We then have the creation of water because of the oxygen that's coming in. And then we have the phosphorylation of ADP to make ATP. Okay, and so here I'm going to kind of show what we have in terms of the overall reaction. We've got glucose that we put in at the beginning from glycolysis. We've got oxygen that we breathe in and we send to the mitochondria to be that final electron acceptor. We have 32 to 38. Again, this range is representing sort of the discrepancy that we see across different texts, across different physiology. So a pregnant woman may actually have a higher rate of ATP production than, say, someone who's elderly or a child or an athlete or so on. So there is that discrepancy that I talked about earlier in terms of the overall values. But we have anywhere from 32 to 38 ATP made as we phosphorylate 32 to 38 ADP. And so on the other end, we end up with carbon dioxide, water, and our ATP that is being produced.